Welcome to the journey into infinity. Today we leave behind the random variables that have finitely many values and go into the sea of infinite but still discrete random variables. Imagine we are tossing a coin until the result is heads. We are interested in how many times will we get tails before we get heads for the first time. In other words, we have a series of independent Bernoulli trials, each with same probability parameter p. Our random variable g will be equal to minimum index of the Bernoulli trial such that the next result is success. We say that such random variable is coming from geometric distribution with parameter p. Today, we want to generate it using R. Let's first choose our parameter p to be equal to 0.3. Let's also define the index I, which we will use to count the number of failures. So we start with I equal to 0. To generate the geometric random variable, we need some sort of loop. A loop that will repeat until we finally get success in the Bernoulli trial. For this purpose, while loop is very useful. While loop takes a logical condition as argument and iterates while this condition is true, or in other words, until this condition becomes false. So what would be our logical condition? Well, it is getting failures in the Bernoulli trials. Remember when we generated true and false with Bernoulli distribution in the episode 2? If we just compare random uniform distribution to probability parameter p, we will get true p% of the times and false minus p% of the times. So exactly like in the Bernoulli trial. So we write while we are getting failures in Bernoulli trials, do increment the index by 1. So here we would be counting how many times we failed. And that's it. When we finally draw a number which is smaller than p, then the logical condition will become false, the loop will stop, and the index will not increment. Our geometric random variable will be the value of the index I. So for instance, in this case, we iterated the loop 2 times before we got a successful trial. If we reset I to 0 and run the loop again, we get 0 this time. You are probably suspecting that R has got built-in function that draws it from geometric distribution. And you are right. The function that is called rgeom for random geometric takes 2 arguments the size of the sample and the probability of getting success. So here we generated the same using the built-in function. Let's generate a big vector of observations. Let's say 10,000. If you want to write big numbers in R, we can use scientific notation. If n is equal to 10,000, so 10 to the power of 4, we can write n equals 1e plus 4, which means exponent of 10 is positive 4. Okay, so the result vector R is equal to R geom with size n and probability p. Let's look at the histogram of R. So what do we see here? It looks like the biggest number we drew is somewhere around 30. That means that in this observation we had around 30 unsuccessful trials before the first successful one. We also see that most probability is cumulated in the low results, like 0 or 1. Looking from a different perspective, the higher the result, the quicker the probability goes to 0. How quickly is it exactly? We need to do some math to find out, and we will do it in the next episode. Thanks for watching. If you have any questions or comments, feel free to post them in the comment section. See you in the next episode.